Hello everyone, this is Miss Risk. We're going to go over today 18.2, which is factors affecting chemical equilibrium. We're going to go over different factors and we're going to explain Le Chatelier's principles and how it affects the system, equilibrium system.
Le Chatelier's principle states that if a stress is applied to a system at equilibrium, the system shifts in the direction that relieves the stress.
All right, and the type of stress that we're talking about is any change that will upset the equilibrium. Okay, and we're going to talk about concentration, temperature, pressure. These are the three that we're going to cover. Now, analogy would be if you're in a store um, and the storekeeper, they have to maintain the shelves full at all times. So full at all time, that's equilibrium. So as buyers take off products off the shelves, that disturbs the equilibrium. So the storekeeper rushes to restore equilibrium and she adds more in. So you want to think of this as when a buyer takes out, that's deficiency that the storekeepers uh, restores and restores equilibrium. Okay, I think that's a very good analogy that I just saw in one of the books. Um, so adjusting concentration, either product or reactant. So adding a reactant increases the number of collisions. It upsets equilibrium. Okay, concentration increases collisions and disturbs the equilibrium or upsets the equilibrium. And it has to shift away from that stress. Okay, so let's start with the pressure. What happens with pressure? As pressure increases, the system will shift to the side with less number of moles. And we're talking about coefficients here, so you pay attention to the number of coefficients and the number in front. Those are number of moles. On this side is a total of 2. On this side is a 3 plus 1. That's 4. So when we increase the pressure, it's going to go to the side with less number of moles. So it's going to shift to the right where the product is. As the pressure decreases, it will shift to the side with more moles. So if increase the pressure, it's going to go to the left, to the reactant side. Now, when we're talking, let's see, when we lower the pistons, it decreases the volume, but it increases the pressure. So if you have a question that gives you increasing the volume, so you know the pressure will go down. Decreasing the volume, like in this case, when you press it down, volume decreases, pressure will increase. Okay, so that's pressure. What about temperature? Increase temperature will shift away from the stress. So wherever do you see that kcal or heat, so it's represented by kcal or heat, and it's going to shift away from it. So it's going to go to the other side. So if the temperature is on the product side, it's going to go to the reactant and vice versa. And if we decrease, there's a deficiency and it's going to rush to help it out. The system is going to rush toward it to restore equilibrium. So think of deficiency, restoring. So it's going to shift toward it. All right, this one is the most common reaction that you see in the environment is the NO2. On a hot day, you find the environment a little bit hazy. Okay, and that's because it shifts. This reaction is happening every day, and when the temperature goes up, it shifts towards NO2. And when the temperature on a cold day is going to be much clearer because it's more shifts more to the N2O4 instead of NO2. Now in the lab, this in a beaker, when you heat it up in the boiling water, it's a tube that has NO2 and N2O4 in it, and when it's heated, it favors NO2. When you heat it, it favors NO2, which is a little bit brownish, and that explains that picture over here. Brownish, hazy a little bit. All right, now the next one is concentration, increasing concentration. So if increasing the concentration of any of these will shift to the other side. So shifts away from stress. So if I increase NH3, it's going to go to the other side. If I decrease NH3, it's going to shift toward the deficiency to make up or to restore equilibrium. Okay? Now, a catalyst. When you add a catalyst to a reaction, it helps to speed up the reaction, but it has no effect on the equilibrium. So no change. So you just write no change. This one, I think, part of your handouts, that with the 18 to do now, or another one that's similar to it. We're going to go over a couple of them. What happens if you add N2? N2 is right here. If you add N2, it's gonna shift to the other side. So it's gonna shift to the right. And when you have an arrow shift to the right, everything on the tip of the arrow is going to increase. Everything on the tail of the arrow is going to decrease. So NH3 will increase, H2 at the tail will decrease. See if I have another one. Let's say we increase the pressure. Increase the pressure is going to go to the side with least, so it's going to shift to the right. NH3 will increase, nitrogen and hydrogen will decrease. Let's see. Decrease the pressure is going to go to the side with more, so it's going to shift to the left, and the tip of the arrow, so hydrogen and nitrogen will increase, NH3 will decrease. So go ahead and complete the handout, and if you have any further questions, I will post another video. I will also post another video for a practice quiz for your next quiz. Okay, good luck. Let me know if you need help.